Okay.
Great. Okay.
Okay.
Right. Well, welcome to everybody who happens to be watching this first attempt at a YouTube Google Hangout for the Royal Astronomical Society. I'm Robert Massey. I'm one of the RAS staff.
And I'm glad to be a guinea pig for this.
Thank you. And it's a pleasure to welcome Lord Rees of Ludlow, who, of course, is Astronomer Royal, past president of the Royal Society, and also of the Royal Astronomical Society. Now, is it okay if I call you Martin in this context?
Yes,
great, excellent, nice and straightforward. So we're here to talk to Martin Rees today about the work that he's going to be presenting and talk for us later on at our ordinary meeting, because as well as his many other activities, he's on the board of the Breakthrough Listen project, which is funded by Yuri Milner, I think, for $100 million for 10 years, a great sum, and its goal is to search for extraterrestrial intelligence. So I think at this point it's probably appropriate for me to ask Martin to tell us a bit more about this project and actually what excites you particularly about it.
Yes. Well, of course, the idea of looking for life in space, even intelligent life, goes back a long way. It's been speculated about for centuries, and there have been searches for the last 50 years. But what's happened now is that this particular wealthy Russian has decided to invest $10 million a year for 10 years in order to have a more systematic and larger search for life than had been done before. Roughly speaking, one day of this new effort would be equivalent to a year of all previous efforts. And what's going to happen is really just looking to see what's out there that looks artificial, a very narrow band signal or some sort of pulsing optical signal or something like that. And what's been done first is to buy time on big existing radio dishes, in particular the Green Bank dish in West Virginia, US, and the Parkes dish in Australia, and put special purpose instrumentation on them. And then they use other telescopes and they have other projects. But it's really a bigger and more systematic effort to be done before.
And when I was reading about the project, it seems to be using optical searches as well, is that right? The Lick Observatory?
Yes, the ones I mentioned were radio searches, but they're using the Lick Observatory to look for optical signals, looking for something which is very narrow band, which could be a laser or something like that, which would be artificial. And also there's a proposal to look for optical flashes, just to scan the whole sky using special purpose instrumentation, just to see if there are occasional flashes.
I suppose the question then comes to me thinking about that is, what kind of energy requirement would you need to generate something that's bright enough that you could see it, tens of light years from the Earth? It sounds like an extraordinary thing to do.
Well, it's not that much, because I think if there were some aliens a few light years away on a nearby star, they could detect evidence of emissions from the Earth already, radars and things like that. And the kind of lasers being talked about for propulsion of spacecraft could be detected even to extragalactic distances. So it's not impossible that there could be something out there. But of course, the important point to say is we have no idea what we're looking for. The aim is simply to look by all possible methods for something which looks peculiar and can't be explained naturally.
So obviously, I suppose it's been said quite often that if we found life elsewhere in the universe, this would be probably one of the most sensational discoveries of all time, even if it's primitive life.
Yes,
change our paradigm.
Yes.
I know you said that. So my question would be, what's your gut feeling about this? Do you think there is intelligent life out there that will, and actually, are we ever likely to meet it?
Well, I think even those who are most optimistic would say there's at most a few % chance of detecting anything by these methods. I think if you ask most people, they would suspect that simple life is fairly widespread. After all, we now know that there are a billion planets like the young Earth elsewhere in our galaxy. And unless life is an incredibly rare fluke, there'll be some life there. But of course, we don't know how likely it is that simple life evolves into anything we call intelligence. And we don't know whether that intelligence would have any sort of technology and what would lead to. My personal betting, actually, is that if there is anything out there that we detect, it will not be anything like us. It'll be some sort of machines which are descended from a civilization like us. And the reason I say that is that if we think of what has happened in the past and will happen in the future on Earth, it's taken 4 billion years for evolution to get to us. But there's 4 billion years ahead. And during that 4 billion years, post-human evolution probably will be electronic, not organic brains. And the epoch when there are intelligences which are organic may be very short compared to the preceding stages and also compared to the later stages. So my betting is that if anything's detected, it won't be any civilization sending a message. It'll be some machine which may have been created by some long dead civilization.
And that takes over from beings, maybe not like ourselves, but in organic beings.
That's right.
I mean, that also sounds as though it would fit in to some extent with some of your previous dystopian books, and whether or not that's a positive development or not, I suppose it depends on your personal perspective.
That depends very much on whether you think these things will be conscious or not. If you think they're sort of beyond humans in their capacities and conscious, then maybe that's good news. But if they're just zombies, then that's a bleak future. And it's very interesting, the philosophical question of whether consciousness is special to the kind of hardware in our skulls, or whether it's an emergent property which they would have as well. That's a very important open question.
Do you think if we did detect something, I know there's been some discussion about how we should respond. Do you think that's a wise thing to do, or is the risk simply so low because any civilization is so far away they're unlikely to reach us?
Well, I think if we detect anything, I would say it's still unlikely to be any kind of message we can decode. It'll be some possible malfunction of some machine or something like that. I suppose there's no harm in sending a message, but I can't relate at all to the people who worry about sending a message, because if there really were more advanced creatures out there, they'd probably know all about us already. So I don't see any reason to be concerned about that.
One of the aspects of this project is unlike, say, a lot of the research you've been involved in, this is privately funded. So my question then is really, do you think that's appropriate for this, or do you think we're likely to see a growth in that, or is this something the government should take seriously and support themselves?
Well, I think it's welcome. Of course, traditionally the governments haven't supported this rather flaky subject, and therefore it has depended very much on the succession of private philanthropists, of which your Melna is the latest. I personally think there'd be no reason why there shouldn't be public support, because if you were to ask people coming out of some science fiction movie, would they like some of the tax from that movie to be hypothecated for search? I think they'd say yes. Indeed, I'd be happier defending a search for SETI to politicians than building an accelerator, for instance. There'd be more public interest. And so I don't see any reason why there shouldn't be public funding, because I think the public would be happy to do this. But on the other hand, it's very good that there are private people who've stepped up to the plate. And of course, one other point to mention is that the people who, in a sense, are often least enthusiastic are astronomers. And the reason for that is that if it comes out of the astronomy budget, it's using up their money and maybe their time on telescopes. So if it were to be publicly funded, I think the funding should be seen as not part of astronomy at all.
That's very fair. I mean,
add on because it's a wider public interest than the rest of astronomy.
She feeds into kind of another question I had actually, which is there, with this data, is there other science you can do with it? Are there other things? Are you simply surveying to answer this one question? And can you find out something about astrophysics, for example, if you don't find out?
Well, certainly one will, because, for instance, one of the most exciting discoveries recently is very strong radio bursts coming from cosmological distances, and that was discovered by radio astronomers. It could have been a byproduct of these searches, and all kinds of things like that will be discovered. And also, there's been interest in peculiar stars and things that look like artifacts out in space, and most of them would prove to be natural. But we discover more about the natural phenomena by this search. And the important thing about this search is that we've no idea what we're looking for. You start off looking at Earth-like planets around nearby stars, but that's just the looking under the lamppost argument, and really you should try and look for everything you can.
Because I think it's surveying 1 million stars, one of the searches.
Well, that's right. There's a big debate about what the balance should be between looking at nearby stars, looking at nearby planets, or looking at huge numbers of stars at the galactic center or in other galaxies, because we've no idea what we're looking for. It could be that there are a very small number of very intense artificial emitters. It could be there are more common ones which are less powerful. So we just don't know, but the idea is to divide the time between looking at the nearby objects and looking at the distant. And of course, as I said, it may be that the signal doesn't come from a planet at all, because if you imagine these machines that they evolve on a planet, they may prefer empty space anyway.
It's a very provocative thought. So a few more questions. One of which I had was, if no signal is found and we carry on expanding these searches, how significant do you think that is? Is it simply a selection thing, just not doing it right, or is it starting to tell us that life on Earth really, or of our type, or generating radio and optical emission this way is exceptionally rare?
Well, it's constraining it, and there's a famous saying in the subject that absence of evidence isn't evidence of absence. So there could be entities out there which are not transmitting, leading a contemplative life, not spending any energy, etc. They could be out there. But also the other point to bear in mind is that we are really only starting these searches. I mean, it's rather like taking a bucket of water in the ocean and saying there's no life in the ocean on the basis of that one bucket, which would not be a good idea, because that's really the stage we're at now. So I think we should try and extend the searches, and the Breakthrough Listen project, which has incidentally broad international support, and the committee that I'm involved in has 20 people, including Chris Lintott and Mark Garrett from the UK and myself. I think we take this as a serious project, and we hope it will generate wide public interest, because indeed some of the data can be chopped up into bits that individuals like in SETI at home and Galaxy Zoo can deal with.
And so there is actually an opportunity for the public to be involved in the analysis of this.
That's very important, and the issue is how you can sort of split up the data and package it so that individuals can have a bit of it.
But imagine being a member of the public who downloads this software and is the person to discover that signal. And it's
Indeed,
the first time.
yes.
Remote though the odds may be, it would be really
well, of course, already amateurs have found very unusual planets by looking through the Kepler data. And in the same way, they may be lucky looking at this data.
Okay. So really, the question for me now is what's next? If you, in this vein, if this project runs its course, and say you probably won't find anything, but we have no idea. If you had to ask the global scientific community, or perhaps we should just talk about humanity, to commit to doing something else, to try to continue the search for life elsewhere, what avenues do you think they should pursue?
Well, I would say we are hoping that there will be more sensitive telescopes for straight astronomy. And I think as they get more sensitive, I'd like to feel that some fraction of their time was used in order to deepen the search, so that we can sample a bit more of the enormous parameter space that's available. And of course, the other point, which I should have mentioned, is that some of the data can be gathered in parallel with other observations. Obviously, you can do better if you have the telescope full time, directed where you want it, but you can get data alongside the other observing programs of that telescope. And so I would hope that whatever telescope we have, then some effort will be spent looking for something artificial, and also that we should be open-minded about what we might find, some artifacts in the solar system, some asteroid that looks especially shiny or odd, and all these things. We've got to be open-minded about what might be there, since we really have no idea what we should be looking for. But it would be hugely important to find something that was manifestly artificial, even if we could make no sense of it. If we could detect a message, that would be, of course, even more exciting. But I would say that that's a second-order unlikelihood compared to detecting something.
That's a great note on which to end this interview. I love the idea of going out and finding a polished asteroid and realizing what the significance of that was. Well, thank you very much for joining us today, Professor Rees, and it's been a pleasure, and I look forward to seeing you talk later on.
Okay, thank
you so much.
Yes, we had lots of background phone noise.
Yeah, we did. We'll get rid of it.
Yeah, okay.
Thank you.